Hi students, today we are going to discuss an important topic, that is dipole field. Okay, today we are going to discuss dipole field. So how we can find the electric field at a point due to a dipole. We know that what is a dipole. Dipole means two equal and opposite charge separated by some distance. That arrangement is called a dipole. And also we know that the total charge of a dipole is 0. Total charge of a dipole is 0. Okay. So here we are going to find out the dipole field in two cases. One, the point on the axis of a dipole, and another one, the point in the equatorial plane of a dipole. In two cases we are going to find out the electric field due to a dipole. Okay, the first case, first we are going to discuss about the electric field at a point on the axis of a dipole. That is the first topic. First we are going to study the electric field at a point on the axis of a dipole. How we can find electric field at a point on the axis of a dipole. So we consider a dipole. We consider a dipole. This is two charges separated by a particular distance, and we consider this charge is plus q and this charge is minus q. I consider this point is A and this point is B, and distance between these two charges is considered to be 2a. 2a is the distance between two charges. Okay, so we consider a dipole. Okay, the length of dipole is 2a, and we have a dipole moment. Dipole moment of the dipole is, dipole moment of dipole is P is equal to Q into 2a, or that is 2qa. That is the dipole moment. Okay, so I consider a point on the axis of a dipole. I consider a point on an axis of a dipole. So this is the axis. So this is, we consider point P at a distance r from the center of a dipole. This is the center of a dipole. So I consider a point P on the axis at a distance r from the center of a dipole. So we want to find out the total electric field at this point. So we need to find the electric field at a point on the axis of a dipole. So we consider a dipole. Okay, having dipole moment P, that is equal to 2 into QA. So we have to find out electric field at a point. We consider point on the axis of the dipole. We consider point P at this distance r from the center of a dipole. So we have to find out the total electric field at this point. We know that equation for finding electric field at a point due to a charge, that is given by, electric field at a point due to charge is given by E is equal to 1 by 4 pi epsilon 0 q divided by r square. Here q is a charge and r is a distance from the charge to that point. Okay, here there are two charges, so plus q, a charge will, electric field will be there at the point P, and minus q, also the electric field at the point P. The total electric field will be sum of electric field due to positive charge and due to the negative charge. Okay, so first we are going to write electric field at a point P. E at electric field at P due to plus q charge, that is represented by E plus. So that E plus is equal to 1 by 4 pi epsilon 0 due to positive charge, Q divided by the distance from the charge to the point, that is taken as BP square. That is equation number 1. So rectified at a point P due to positive charge is E plus equal to 1 by 4 pi epsilon 0 Q by BP square. For BP means the distance from the charge to that point. So we need to find out the value of BP. We know that the distance from center to B is taken as, this distance is A. A distance from O to P is R. So BP can be represented by R minus A, because distance from center to P is R, from O to B. O to P is R and O to B is A. So BP will be R minus A. So substituting that value here in equation number 1, we get E plus is equal to 1 by 4 pi epsilon 0 Q divided by BP mean R minus A. So it will be R minus A whole square. That is equation number 2. So this is electric field at a point P due to positive charge. So direction of electric field is away from P. So this is the direction of E plus. E plus is away from P, is away from the point P. Okay, it's away from B to P. Okay, that is the direction of electric field due to positively charged. So next we need to find out electric field at a point due to negative charge. So this is about the electric field at a point due to positive charge, that is E plus is equal to 1 by 4 pi epsilon 0 Q divided by R minus A whole square. This is electric field at a point due to positive charge. Next we have to find out electric field at a point due to negative charge, that is electric field E at P due to negative charge minus Q. That is represented by E minus equal to E minus equal to 1 by 4 pi epsilon 0 minus Q divided by distance A to P, that is AP square. So distance from the charge to the point is AP, so we taken as AP square. So what is the value of AP? AP is the distance from A to P, but we know the distance from O to P. O to P distance is R and A to O distance is A, because O is the center of the dipole. So this distance is taken as A. So AP is equal to R plus A. So substituting in equation number 3, we get E minus is equal to 1 by 4 pi epsilon 0 minus Q divided by R plus A whole square. That's equation number 4. So this is the equation for finding electric field at a point P due to positively charged, and E minus, that is equal to 1 by 4 pi epsilon 0 minus Q divided by R plus A whole square. That is the equation of finding electric field at a point P due to minus Q term. But the direction of electric field is towards BP direction. Okay, this is the direction of electric field from, okay, the direction of electric field E minus, okay, towards left from the point P. E plus is towards right from the point P, and E minus is towards left the point P. Okay, so we have to find out the total electric field at the point P. The total electric field is represented by E axial. E axial is equal to E plus plus E minus. The total electric field at the point P is sum of E plus and E minus. So substituting the value, what we'll get? E axial y are representing E axial, we are finding rectified the point P. P is on the axis. So E axial equal to E plus is 1 by 4 pi epsilon 0 Q divided by R minus A whole square plus, what is E minus? E minus is 1 by 4 pi epsilon 0 minus Q divided by R plus A whole square. R plus A whole square. Okay. In this equation, 1 by 4 pi epsilon 0 is common, Q is common, so we are taking it outside, so we get E axial is equal to Q by 4 pi epsilon 0 into 1 by R minus A whole square minus, here negative sign, minus 1 by R plus A whole square. This is equation number 5. Okay, here 1 by 4 pi epsilon 0, Q is constant, we are taking it outside, so we get Q by 4 pi epsilon 0, 1 by R minus A whole square minus 1 by R plus A whole square. Then solve this equation 5. Solve this equation 5. This equation 5. What we can write? E axial is equal to Q by 4 pi epsilon 0. We are cross multiplying, so we get it become R plus A whole square minus R minus A whole square divided by R minus A whole square into R plus A whole square. Clear? So this is equation number 6. We can expand this in the form of A plus B whole square and this in the form of A minus B whole square. We expand this R plus A whole square in the form of A plus B whole square and this in the form of R A minus B whole square. Okay, and solve, we get a value, and here also, here R minus A into R plus A. Here I am going to rearrange this equation like this. E axial is equal to Q by 4 pi epsilon 0, expanding this R square plus 2RA plus A square minus, expanding this R square minus 2RA plus A square all divided by, here I am going to write like this, R minus A, R plus A whole square. Okay. Here, when we are taking the minus inside this bracket, when we are taking this negative sign inside the bracket, here become minus R square, this become plus, and this also minus R square. Then solving this equation number 7, we get E axial is equal to Q divided by 4 pi epsilon 0 into 4RA divided by, here this term written as R square minus A square whole square. So the equation number 8. The denominator, this A plus B into A minus B, so it become R square minus A square whole square. So we get equation number 6. So we got equation E axial equal to Q by 4 pi epsilon 0 4R A divided by R square minus A square whole square. Then again rearranging, E axial is equal to 1 by 4 pi epsilon 0. I am splitting 4 into 2. So I am writing it is 2R into 2QA divided by R square minus A square whole square. Okay, splitting 4 into 2 into 2 like, so we get 1 by 4 pi epsilon 0 2r into 2qa divided by r square minus a square raised to all square. But we know that 2qa is equal to p. We know that 2qa is equal to p. So the above equation we can again write like this. E axial is equal to 1 by 4 pi epsilon 0 2rp by r square minus a square whole square. This equation number 9. Suppose here we consider the length of a dipole is small. That is, A is less than, very less than R. Suppose we consider A is less than R, dipole length is small. So the denominator of the equation R square minus A square whole square is changes to R raised to 4. If A is very less than that, that means dipole length is small compared to distance from center to the point. So denominator r square minus a square whole square. So a is very small, so a square is very small. So we can neglecting the a square, so we get r raised to 4. So equation number 9 changes to E axial is equal to 1 by 4 pi epsilon 0 2rp by r raised to 4. 2rp by r raised to 4, that is equation number 10. But here one r and one r we can cancel. Okay, r in the denominator we can cancel. So we get E axial is equal to 1 by 4 pi epsilon 0 2p by r cube. E axial equal to 1 by 4 pi epsilon 0 2p by r cube, that is in vector. E vector is equal to 1 by 4 pi epsilon 0 2p vector by r cube. So this is the equation for finding electric field at a point on a dipole, at a point on the axis of a dipole. So E axial equal to 1 by 4 pi epsilon 0 2p by r cube. Here p is the dipole moment and r is the distance from center to the point. Okay, so this is the equation of finding electric field at a point on the axis of a electric dipole.